I clearly need to hold it closer to my mouth. There you go. Hello, everyone. I am Dan. I'll be talking about reducing the zero results rate for search on Wikipedia. And I've already told you who I am, but there I am. I'm Dan. So I'm part of the discovery department. This is our wonderful slide. So building the anonymous path of discovery to a trusted and relevant source of knowledge. That's our tagline. But what does that mean? Well, if you've been keeping up with my presentations and you checked in with the last one of the last slides was this. So this quarter, we're dedicated to reducing the zero results rate. Users should never get zero results when they search. Well, now I'm here to tell you what we've been doing about it. So who's getting zero results? Why is this an interesting problem to us? Why is this what we've chosen to tackle first, the zero results problem? So we've analyzed a lot of the queries that got zero results. And we found out that about 30% of users, 30% of queries return zero results. And there were two reasons that we chose to tackle this. First of all, if we want to serve people relevant results, serving them nothing, by definition, means we've not served them anything relevant. And secondly, we just had a practical choice that giving users either some results or zero results is very easy to analyze. So as a first problem for the team to tackle, it made a lot of sense because we could really measure what we were doing. We want to move on and start measuring search satisfaction, making sure that we're serving users relevant results, but that's much harder than checking whether we're giving them something or nothing. So this is why we chose to tackle this first. So I'm going to give you a couple of examples of the most prominent kinds of queries that we're getting where we're giving people nothing. And if you want to follow along, here's the URL. This is some analysis that Trey from the discovery team put together. It's published on MediaWiki.org. bit.ly/zero results. So DOI queries. So what are these? What's a DOI? It's basically an ISBN for books. And footnote, ISBN for books is ISBN. ISBN for scientific papers. There you go. So it's a unique identifier, and it tells you exactly, it uniquely identifies the scientific paper. So for example, these bottom two are DOIs. This top one is actually someone searching for either one DOI or another DOI. And Daria, let me give you the microphone so people can hear.
Quick comment that I can tell you a lot about who's behind these searches.
So can I. So it turns out it's actually a little app called Legato. Checks if Wikipedia has any citations for a paper. And so, we were like, oh, well, we should fix this. We should help them find things. But they're searching for things that aren't in Wikipedia. So actually giving them nothing is right. Most papers, if there's a scientist somewhere and they're checking to see if their paper's in Wikipedia, chances are it isn't. So giving nothing is right. And apparently the volume of requests may actually be a configuration issue. We're reaching out to all of these people and that we've identified here and telling them that, asking them whether we think they're doing something wrong. So Thomas just asked how large the volume is here. This one varies a lot. It can go from 3 or 4% of total zero results queries to about 20, if not a little bit higher than that. So that's a lot of traffic. That's given that 30% of zero results queries, 30% of queries give zero results, and it's 20% of that. It's actually a lot. So the second one that we identified is Unix timestamps, as we've called it. So it's a Unix timestamp, and then colon, and then the title of an article. And it's always the title of an article that already exists. So we tried to identify who was responsible for this, and this was the answer. Me. This patch that I wrote for the Android app a while ago. So the Wikipedians among us will notice something about this. It's almost like that it's a namespace, colon, an article title. So I was trying to fix a bug where the namespace of pages wasn't saved. It was just putting null in instead. And then it was dumping the entire thing into the actual, the title. And I broke it. So in particular, my favorite quote from this patch is, "The old entries are still compatible with the new system." Turns out they're not. So anyway, we reached out to the Android guys. We said, hey, I broke your app. Will you fix it, please? They did fix it. So this typically was around 4 to 5% of the zero results queries. And we've got that not actually down to zero because some people just don't update their app and they're still. So the funny thing is, the users didn't really notice that this was happening because the queries that they were issuing were giving them reading suggestions at the bottom of the main page. And since they got nothing, it completely hid the box. So they had no idea that this was happening. If only we had more tests. So then, Layla. What was that again? No, so this is based on API logs. Yeah, oh yeah, sorry. Layla asked if everything is based on apps data. No, this is based on Cirrus search logs and API logs. So given that the apps only make up about 1 to 2% of our traffic, but yet these made up 5% of our zero results queries, that tells you something. Sure. Mm-hmm. Yeah, so Dario asked, are we distinguishing between human and applications that are hitting our API? We're not. We want to. It's easier for things like Legato, where they're actually giving us a consistent user agent and it's coming from a consistent set of IPs to identify them as bots. But the general problem of identifying whether some particular traffic is from a human or is from a robot is much harder. So we want to work on that more and detect that more generally. Trey. Yeah, so this trader said this title and link from an article. We couldn't tell that it was a bot, but the volume and the frequency of the requests made us think it really wasn't a human. So yeah, so this was actually a title of an article and then and a link from the article. And it is not a mistake that the title has underscores and the link doesn't. That was actually the exact signature of the requests. So Argentine football team, football league system, and football in Moldova. I'm not really sure what the person is looking for there. So all of these actually ended up coming from a single IP, and it accounted for about 5% of total search traffic. So that's not 5% of zero results. That's 1 in 20 queries we were getting was from this person. And actually, we've been running a lot of A/B tests, and this person managed to get bucketed into one of our A/B tests. And then we ended up having far more requests in one bucket than the other. And we thought that A/B testing thing was broken, but actually it was just this guy. We had to block him. He was violating our terms of use, which was unfortunate. But we've got in touch with his ISP, and we're trying to rectify this solution. But actually, this only kind of scratches the surface. Like I said, these were the 3 most prominent, and on a low day, they were about 3 or 4%. On a high day, they were much higher. But there's still a lot that's actually happening with zero results. Lots of people getting zero results that aren't mentioned here. So how do we help them? So generally, we've came up with about 3 different patterns of solutions for attacking the zero results rate problem. So the first is query forwarding. So these are general solutions. We do different things with them. So I'll give you examples. So query forwarding, that's where we, based on some heuristic, decide that the user searched for one thing and they actually meant to search for something else, and we run that search for them instead. Or we can take the query, not modify the query, but think, actually, you didn't mean to search here, you meant to search somewhere else and run it against a different index. So 2 examples there are if the person typed something in and they got a did you mean suggestion provided by the search API, but 0 results, we just run the did you mean suggestion instead and give them the results from that. We tell them that this has happened. Google does something like this. And the second one is if the user's typing in a query in Cyrillic, then they into the English Wikipedia, they might not want the English Wikipedia. The thing is they might, so this is kind of harder. But if we can detect that they're Russian words, say, for example, and there is no article by that title on the English Wikipedia, but there is on the Russian, we can maybe run the search on the Russian Wikipedia instead. So these are ideas. These are not things we've done. I will cover what we have done. So the second general thing is Elasticsearch parameter improvements. So Elasticsearch is the open source software that backs our search and builds the search index and so on. So we thought, well, maybe we can tweak the parameters. Elasticsearch has a lot of different parameters in there. maybe we can tweak them and we can get people better results. And the third is to use different search backends. So still within Elastic, there's a lot of different things that you can use. It's like prefix searches, full text searches, and a third kind. I'll get into that. So we had a lot of infrastructure to build. So like the three things that we did first, we wrote a lightweight A/B testing system for Cirrus Search. So as I mentioned, that buckets users according to a sampling ratio, so that we've got an even sample of users, and then it gives them different search parameters. So it's really easy now. You just write a little config change, like 10 lines of code or so, and you can run an A/B test. The second thing is we created a test environment to try crazy new things. So what this consisted of was taking the entire search index for English Wikipedia and importing it into a wiki in Labs. I'll give you a link to that wiki later. So on the surface of it, that kind of creates this broken experience on that wiki. You search for things, you choose a result, and then the article doesn't exist, but it's not actually really intended for users to test. It lets us take a set of queries from the English Wikipedia, say, change parameters, and then replay the queries against the test, and then see what changed. So this lets us try like really crazy things, which we don't know whether it'll break stuff or make things better without actually having to break things for people. And the third thing that we've been doing is lots of dashboarding and lots of analysis. So we've made a search dashboard. It's available there, searchdata.wmflabs.org. There's loads of stuff in it. We've got our KPIs in there. And we've been doing A/B tests, so we've been analyzing the results of the A/B tests, producing reports. Those reports are on Meta, and I'll go into that. So what have we actually done, like in terms of features for users? So this is the first thing that I mentioned. Here I searched for Manchester, but I put 2 R's on the end. And you can see it says, showing results for Manchester, search instead for Manchester. And that is, there were 0 results for the actual query, but I was given a suggestion. So we forwarded the query along. And as you can see, I get results now. So that's good. Like we've taken something where someone got 0 results, and we've given them results based on what they put in. We've also run A/B tests to figure out if there are better search parameters. So this is the screenshot of the config change. The results are at the top there. So what we did here is we slightly tweaked the confidence. So we made it, previously it was set so that the Elasticsearch had to be very confident that the suggestion it had was better than what you typed in. For the A/B test, we said, well, what if we make it just as confident? So if you get nothing, then it has something that it thinks is as good but not better, then it will give you that instead. And turned out that created a statistically significant change. However, the magnitude of it was so small with the amount of traffic that we've got that we basically didn't achieve anything. We made it better for like 3 people out of the tens of thousands that use the site. So not really that good. So how does the 0 results rate look? So this is just taken from our dashboard. And the top line is the 0 results rate. So you can see it's about 30% at the start of June. The bottom rate is the rate of change. So this is helping us track how it's changing and like what effect we're having. And as you can see, we've not actually had an effect. We've put a lot of effort in. We understand the problem a lot more. We understand who's getting 0 results, but we've not achieved anything. And this like interesting kind of weekly variation here, that the 0 results rate goes up at the start of the week and then down at the end. Funny. Still don't understand that properly. So what's next? If we've done all these things and we've not achieved anything in terms of making search actually better for our users, if we only understand it more, we need to try something more radical. So how does this sound for radical? Why don't we generate our search results in a completely different way? Okay, I got a few reactions. That's good. So what do I mean by that? So it turns out that the answer to a lot of questions that we have about search are maybe the people that wrote Elasticsearch actually have an answer, and we just haven't unlocked the power of Elasticsearch. This is an example. So this is the labs instance that I mentioned, suggesti.wmflabs.org. If you go to /wiki, then it takes you to the wiki, which is the one that has no content but has the entire search index for English Wikipedia in it. But if you go to /suggest.html, it's more interesting. So what you can do is you can type in a query on the box on the left, and it will run it against plain old prefix search, which is what we use right now on desktop, at the box at the top right, and on other platforms. And it also runs it against a thing called the Elastic Completion Suggester. So, and So you can see the results here. So in this case, I searched for Jurassic and I misspelt Jurassic. The reason I chose that is because that was a query that we found that was generating 0 results a lot, was people were searching for Jurassic World and misspelling Jurassic. Normally, these things are handled by the creation of redirects. So I'm sure you're all familiar with people on various different wikis create redirects from one title to another. A good example of that is the article title corn redirects to maize, because maize is the accepted name. But you also get things like, for example, if you type in the name of a Russian place in Russian, then it will take you to that article in English on the English Wikipedia. What I personally think is interesting about the suggester here is that it actually gave me Jurassic World as the top result without having to rely on a redirect to do it. It figured it out on its own. And it was 100 milliseconds faster at producing those suggestions than prefix search. And so there's some documentation here. At the bottom right, there's Elasticsearch page on the suggester, and they talk about how like the reason why people like prefix search is it's really fast, and completion suggester can actually be even faster. So is this actually a viable alternative to prefix search? I may have convinced you with that one query, but how will we actually know? So as I mentioned, we can replay queries. So what we did here is, I'll give you the summary. We took all of the queries that gave 0 results in a very small time period on the English Wikipedia. And then we replayed those queries against prefix search, and we got 100% 0 results, as you would expect. And we replayed them against the completion suggester, and we got 62%, which means that 38%, so about 4 out of 10, 2 out of 5, queries which previously gave the user nothing now give them something, which is good. But that wouldn't tell us if there were people that also got results previously that didn't get results now. So we played a sampled set of queries which contained both results and not results. And the 0 results rate for prefix search was 32%, and for the completion suggester was 19%. So it even works there. It cuts it by about a third. But the biggest question I have here is, this, as I mentioned, this is easy, right? We know that they got something. Do we know that what they got was actually right? Like, you can make it, you can give people results by generating them random results. That will solve the 0 results rate problem, but it won't actually make a good search. So what are we going to do about that? It's promising, right? It's 40% reduction. But how do we really know? Well, we've deployed the API to production. It's actually there right now in production. If you test it, you'll get an error. So the reason that we're doing that is we're building the index. The API is there, but the data that's backing it isn't. But this doesn't actually change search. We've just deployed the API, and we're going to use it for experimentation and for running an A/B test, as I mentioned, A/B testing infrastructure. So there are a couple of different possibilities for what we could do there. We could do it on desktop. We could do it on the mobile apps. We could do it on mobile web. We're not entirely sure which we'll pick yet. And you could do it in the client or the server. So we've got a couple of questions, but it was just deployed yesterday. But it's really promising, and it's more radical. And don't thank me yet, and I'm not going to thank you yet, because I have one more thing I want to mention. So another possibility is we did a survey, which Moise put together, asking people what the problems that they identified with search were. And lots of people were typing in queries into the English Wikipedia or other wikis in a different language. And you might ask, why do people do that, right? They're on the English Wikipedia. Well, as I'm sure you've experienced from talking to people, people don't really know what Wikipedia is. They don't know that there are lots of other wikis. People just call it wiki, even. So the fact that at the top right of the page, the search box, the fact that at the top left of the page, there's a thing that's in a different language, maybe the interface is in a different language, pretty much the only visual distinguishing factor. People don't necessarily know that they're the language of the wiki that they're on. And they shouldn't really have to either. Search should be smart enough that you can just figure out what you want, right? So something that we're actually investigating at the minute is trying to detect the user's language of the query that they wrote and run it against a different wiki and just give them the results for the wiki that they wanted. And you might ask us, how are we going to detect the language? Well, it turns out that there's a lot of power in Elasticsearch that we haven't unlocked. There's actually an Elasticsearch plugin that does this. The difficulty, of course, is very short queries. it might be hard to figure out what the user's language is. But fortunately, we have this thing where we can replay queries and figure out. So we've just begun experimentation with that. Slightly trickier than it sounds as well for technical reasons. We needed to change it so that we had the correct parameters. Because the query is being run from one wiki and it's passing it on to another, it didn't necessarily have the correct search parameters for the other wiki. So it was kind of generating strange results sometimes. So that is what we've got planned next. Thank you. So lots of people ask questions during. I'm happy to take questions afterwards as well. Will the microphone over there work for questions? Yeah? So if you want to stand up, I can run around and give you microphones as well, but stretch.
Okay. Does it work? Okay. So you showed how you tested whether the new system with a completer reduces the number of zero results. But did you guys check to see that it doesn't come at the expense of existing results? Because I think from what you showed, it kind of like you did two tests, one of them 100% zero results that reduced to zero results, and then the other one mixed, and it reduced to zero results. But did it, did maybe take something that was 100% non-zero, like 0% zero results, and see if it doesn't come in that expense. If that makes
we need
sense.
to do a lot more testing before we can really figure this out. And I'm concerned, as I said, I'm concerned about the relevance as well. Like that Jurassic World example is promising because it figured out what you probably wanted on its own. But it is entirely possible that there are going to be cases where it's not giving people what they want. So something that we're working on right now and is a event logging schema called test search satisfaction. This tries to measure, using a approach that we found in the literature, whether users are actually liking the results that they get. A naive way that you can do that is just to measure whether they clicked on something, right? If they clicked on a result from the search, then they probably got what they wanted. But what if they hit back really fast? Then we've counted them as a success. And then if they try the second result, we've counted them as a success again. So then we've got like, hey, this person made 6 searches and got 6 success. And actually what happened was they were viewing a result, hitting back, viewing a result, hitting back, viewing a result, hitting back. So this is what this scheme is meant to do. It's meant to try and measure that, but we're testing it. So in an ideal world, what we would do is we would measure the zero results rate alongside the search satisfaction so that we can see like what the trade-off is. Ideally, we would reduce results and people would be more happy, but maybe there's a trade-off we have to make. Short of that, we're going to have to try a different way. Maybe we just have to use the conversion that I mentioned, like are people clicking, and run more experiments ourselves. Sorry? Sure. I'm not actually. So Dario asked, is all of this based on titles? Is the suggester based on titles? We are doing work on full text search as well ourselves. I'm not sure whether the suggester takes into account the only titles or not, or whether it also takes into account the full text. Because, like, for example, there is no article by the title Jurassic, but it managed to figure out what I wanted anyway. I don't know how it's doing that. This is like is really early experimentation, and we're still not entirely sure. Oh, and the other thing is we're also not sure of the scoring algorithm that actually gives you the suggestions. So, because previously it was really, really naive, and we're kind of building it up a little bit. So there's lots of open questions around the suggester. Any other questions? Okay. Well, if you want to scrutinize our dashboards, as I mentioned, it's all there. If you want to ask us questions, send an email to our list. Email me, speak to me on IRC. Yeah, I'm available. Thank you.